Hello, I'm Damian Sserunkuma from Nkumba University, and we are here with a club called NUCITA. NUCITA stands for Nkumba University Computing and Information Technology Association. This club was basically formed in 2008 by a group of students doing IT and computer science. We want to learn how to network and how to have a hands-on practical session with the networks. A computer network, we can simply call it an interconnection of computing devices together with the common purpose of sharing data and information. To establish a network, we need two gadgets to communicate with each other. They could be laptops, they could be phones, they could be anything, as long as they are digital devices that are establishing a network. In this session, we shall learn how to create a cable, a network cable, or what we call an Ethernet cable. We have a number of tools that we shall need. One is a crimping tool that is used to create or terminate cables. We need RJ45 connectors, and then we also need a twisted pair cable. These twisted pair cables come in two different formats. We have what we call a shielded twisted pair cable, and then the unshielded twisted pair cable. The twisted pair cable normally looks like that when you buy it. You have a bigger roll. This is just a representation of what a cable looks like when you buy it. And this is just a piece taken or cut from a bigger roll of a cable. In this piece, we are going to create a sample cable that we shall need to establish a network. There are different topologies that we can talk about in this session, possibly. A topology is how you arrange computers on a network. The computers that are connected on a network are also known as clients or nodes. The topologies that I'm talking about include the peer-to-peer network topology that involves at least two gadgets. Then we have what we call a bus topology that involves all computers connected to one main cable, and that cable is what we call a backbone. All gadgets that are connected to that backbone, normally they connect through what we call a coaxial cable. Then we also have what we call a star topology. The star topology, we have basically all gadgets, all computer devices, all communication devices connected to one central device, which can be, in this case, either a network switch, a network hub, or a router. We also have another mesh topology. The mesh topology, as long as you want to establish what we call a mesh topology, you have to ensure that all gadgets, all computers are connected on a network. But when you're establishing it, you have to make sure that every single computer is connected to all computers on that network. That way, you will have established what we call a mesh topology. We also have another topology called a ring topology. In the ring topology, we basically have all gadgets, communication devices connected in a circular format. So in that type of topology, we basically have one computer connected to two other computers in a circular format. That type of topology is also known as a token ring topology. In the token ring, we basically have a token, which is a digital envelope. Whichever computer that wants to communicate a message to one computer to another computer, that message is packaged up in what we call a token. A token passes around the network. That message or the job that is taken around the network has two addresses. It has the sender address and the receiver address. So whichever machine it goes to, the machine checks whether it is the owner of that address. And if that message goes through to another machine and it gets the destination machine, The destination machine unpacks the message, reads the message, then impacts the message as message successfully delivered. The token goes ahead through the line until it reaches the sender. That type of topology is what we call a ring topology. Then we also have the last topology that we call the hybrid topology. In the hybrid topology, we basically have two topologies combined into one. We can choose to have a bus topology connected to a star topology, and that way we shall have what we call a hybrid topology.